Hi there. Now for this question we're asked to find the exact gradient for this curve here, y equals the root of 4x minus 7 plus 4x all divided by 2x plus 1 when x equals 4. So to do this I've got to differentiate this. That will give me the gradient in general, and then substitute when x equals 4, and that will give me the gradient at that point. So in order to differentiate this, I'm going to think of the root then of 4x minus 7 as 4x minus 7 all to the power half. And then we've got plus the fraction here, 4x all divided by 2x plus 1. Now for this first term, if I'm going to differentiate this, I'm going to need the chain rule. And for this one here, this fraction, because I've got two functions of x, one on the top, one on the bottom, I'm going to use the quotient rule. There's no real need to bring the 2x plus 1 to the top and call it 4x times 2x plus 1 all to the power minus 1. If you do that, you're going to have to use the product rule. You can do, but it's going to be longer in my opinion. So I'm going to go for the quotient rule on that one. So let's start off then. We've got dy by dx. I'm assuming that you're familiar with the chain rule here. I'll take you slowly through it, but you should be able to differentiate this fairly quickly. What I do is I think of 4x minus 7 as, say, t. So in my mind, I wouldn't normally write this down, but I will do it here just to show you what I'm thinking. I would let t equal 4x minus 7. So what I've got, if I just called this y, okay, I would say therefore y equals t to the power half. And so when it comes to finding dy by dx, I turn to the chain rule. Dy dx then is given by dy by dt multiplied with dt by dx. Okay, so hopefully you're familiar with that. Let's just box that off. Okay, so that's the chain rule. So when it comes then to differentiating this term here, I think of this as t to the half. So we differentiate t to the half with respect to t first of all. That's dy dt there. So you're going to get a half t to the power minus a half. But instead of writing t remember is 4x minus 7. And so that be to the power minus a half. Half t to the power minus a half then. So that's that part. Now I need to multiply it by the differential of t with respect to x. Well, t was 4x minus 7, so if you differentiate that with respect to x, you just got 4. All right? So that's the differential then of 4x minus 7 to the power half. Next we come on to differentiating this term, and I said I'm going to do it by the quotient rule. And for the quotient rule, remember that if you've got a fraction, it's going to be the bottom of the fraction, first of all, 2x plus 1, multiplied by the differential of the numerator. Differential of 4x is 4. And then from this we subtract. We put the numerator down, 4x, the top of the fraction, and multiply it with the differential of the denominator. Differentiating 2x plus 1 with respect to x just gives us 2. And it's all over the denominator squared. Okay, so that's the quotient rule, which you should be familiar with. So cleaning this up, we've got half of 4, which is 2. And that's going to be all divided by, because we've got a negative power here, 4x minus 7 to the power minus half. Remember, it is 1 over the square root of 4x minus 7. So multiplying it with the 2 just gives us 2 over the square root then of 4x minus 7. And then we've got plus, and I can see that if we multiply this out, we're going to get 8x plus 4, and then we've got minus 8x. So we're just left with 4 on the top, all divided by 2x plus 1 all squared. So all I need to do now is just say when x equals 4, what do we get for dy by dx? Basically the gradient then at x equals 4. Well, for this one, we're going to have 2 divided by, and if x is 4, we get 4 4s are 16, take 7 is 9, square root of 9 is 3. And then for this term, when x is 4, you've got 2 4s are 8, plus 1 is 9, 9 squared is 81, so you get 4 over 81. And if you add these two together, I can see that if I multiply top and bottom here by 27, I'm going to get 54 81st there. 54 81st plus another 4 81st is going to equal 58 81st. They want the exact gradient. That doesn't cancel down any further. So therefore I can say then that the gradient equals 58 over 81 when x equals 4. Okay, so hopefully you're okay with that.